A single AWS VPC is easy to reason about. The challenge starts when production, development, security, shared services, analytics, and partner access no longer belong in one flat network. Suddenly, the question is not only whether these systems can connect, the real question is how they should connect without creating future pain. AWS gives you several answers, but they do not mean the same thing. Some patterns connect two whole networks, some publish one private service, some create an application layer, some are regional routing hubs, some are global policy constructs. If you reach for the first service you recognize, you can build a peering spider web, lose route ownership, duplicate security controls, and create hidden blast radius. What looks simple on day one can become the thing that slows every later architecture decision. So in this tutorial, I want to give you the senior engineer decision model. By the end, you should know when VPC peering is enough, when Transit Gateway becomes better, and when PrivateLink, VPC Lattice, or Cloud WAN solve a different class of problem. We are going to keep this practical. First, I will show you the 6 AWS connectivity patterns as a simple map. Then we will connect them to one realistic business case instead of leaving the topic in theory. Imagine a fintech platform with separate production, shared services, security, analytics, and partner-facing workloads. Some of those workloads live in the United Kingdom, some in another AWS region, and some need carefully limited access from outside the core network. By the end, you should understand the architecture shape, the traffic flow, the business use case, and the production trade-offs behind each option. I want you to leave knowing not only what the services are, but why experienced teams choose one over another. Here is the rule I want you to carry through the whole lesson. Start with connectivity scope, trust boundaries, and operating model first. Then choose the AWS service that matches them. That order prevents most design mistakes. VPC peering is the simplest option. It is a private connection between two VPCs, and both sides route directly to each other over private addresses. Think of it as a direct relationship, not a shared routing fabric. Transit Gateway is the regional hub model. Many VPCs and customer networks can attach to one central routing hub, and that hub decides how east-west traffic should move inside the region. Transit Gateway peering extends that hub model across regions. One transit gateway can peer with another, so regional hubs remain regional, but approved cross-region routes can still exist where the business truly needs them. PrivateLink, VPC Lattice, and Cloud WAN solve narrower but different problems. PrivateLink publishes one private service. VPC Lattice creates a managed application networking layer. Cloud WAN gives you global policy and visibility across a much larger estate. Use VPC peering when the relationship is small, direct, and easy to explain. One application VPC reaching one data VPC, or one production VPC reaching one shared services VPC, is where peering often feels natural. Operationally, each side still owns its routes and controls. You create the peering connection, accept it, add the routes manually, and make sure security rules allow only what should cross that boundary. Nothing about peering removes design discipline. The limitations matter. VPC peering is one-to-one. It is not transitive. Overlapping CIDR ranges prevent it completely, and one peer cannot borrow another peer's NAT gateway, internet gateway, VPN, or direct connect path as a transit shortcut. So the production queue is simple. If the trust model is direct, the number of VPC relationships is small, and you do not need a central routing layer, peering is often the clean answer. If any of those assumptions stop being true, start looking at the hub model instead. When the environment grows beyond a few direct relationships, Transit Gateway becomes easier to operate. Many VPCs can attach to one regional hub, so the network stops looking like a spider web and starts looking like a deliberate routing design. This is where route tables and segmentation start to matter. Production does not always need to talk to development. Shared services might need wide reach. Inspection or security paths might need to see traffic from several VPCs. The hub lets you express those rules more centrally. If the business operates in more than one region, Transit Gateway Peering lets one regional hub connect to another. That cross-region path still needs deliberate routing, and the peering attachment becomes a controlled backbone link between the regional hubs. This is why strong teams often create a dedicated network account. The goal is not only to connect VPCs, the goal is to own routing, policy, inspection paths, and change control from a place that is bigger than any one application team. PrivateLink solves a narrower problem, and that is exactly why it is useful. Sometimes a consumer should reach one service privately, but should not gain network reach into the rest of the provider VPC. That makes PrivateLink powerful for platform APIs, partner services, payments integrations, or shared internal capabilities. The consumer gets a private path. The provider keeps tighter control over what is actually reachable. VPC Lattice solves a different challenge. Modern applications often span many teams, many accounts, and many VPCs. VPC Lattice gives you a managed application networking layer with service discovery, routing, policy, and observability across that environment. So keep the distinction simple. If you want to publish one private service, think PrivateLink. If you want many services to live inside a consistent application networking plane, think VPC Lattice. They are related to private connectivity, but they are not interchangeable. Cloud WAN enters the conversation when the estate becomes truly global. It helps you build, manage, and monitor a unified network across regions, VPCs, branches, and data centers with central policy and visibility. That does not mean Cloud WAN replaces every regional design choice. In many environments, regional transit gateways still make sense. Cloud WAN becomes the higher-level structure that unifies those regional decisions and makes the global network easier to govern. No AWS service removes the need for sound network design. Overlapping CIDR ranges still matter. DNS ownership still matters. Segmentation still matters. Cost visibility still matters. And someone still needs clear authority over who can create, change, and approve connectivity paths. Here is the decision model. Two directly trusted VPCs, think peering. Many regional VPCs or hybrid paths, think Transit Gateway. Cross-region hubs, think Transit Gateway Peering. One private shared service, think PrivateLink. Many services across many VPCs, think VPC Lattice. Global multi-region networking, think Cloud WAN. Now bring the fintech example together. Use direct peering only where the relationship is small and explicit. Use a regional transit gateway for the main east-west network. Use transit gateway peering or Cloud WAN when the estate becomes truly multi-region. Use PrivateLink when a partner or internal platform should expose only one private capability. Use VPC Lattice when many services need a shared application networking plane with policy and observability across VPC boundaries. If you remember 5 questions, the right choice becomes much easier. What is connecting? How many environments are involved? Does the path need to stay private to one service or open to a full network? Is the design regional or global? And who operates the routing and policy over time? That is how experienced teams stop drawing random lines between boxes and start building governed connectivity on purpose. At Trustscrin, we are building tools around exactly this kind of architecture to delivery problem, and I will show more of that journey in future videos.